Hey, hi and welcome back. Now let's complete the rest of the circuitry of Atmega 328 microcontroller. Okay, so now let's start with this video, which is about understanding circuit of microcontroller part 2. So in previous video, we discussed the VCC and AVCC pins, and along with that, we also discussed these capacitors which are connected on each and every VCC and AVCC pin. And after that, we also discussed this reset circuitry. Okay. Now in this video, we are going to discuss this debug/programming header and its interfacing with the microcontroller. And after that, we will discuss this crystal section. Okay. You know, when we discussed the pin configuration of microcontroller, at that time we saw that there is actually one interface which is called as SPI, which stands for Serial Peripheral Interface. Okay. And we saw that there are actually different pins in the SPI interface. The first one is MISO pin, which stands for Master In, Slave Out. Then the next pin is MOSI, which stands for Master Out, Slave In. Then there is actually one more pin which is called as SCK pin, which is Serial Clock pin. And after that, in the end, there is one pin which is Slave Select pin. Okay. So these are actually the pins of SPI interface. Okay. And out of all these 4 pins, we actually use these pins in order to program the code in the microcontroller. Okay. When we deal with the programming of the code in the microcontroller, at that time, we don't call it as SPI interface. Okay. We actually call it as ICSP interface or ISP interface. Okay. ICSP stands for In-Circuit Serial Programming, or it is also called as ISP interface, which stands for In-Circuit Serial Programming Interface. Okay, so both are actually the same. So when we use this particular interface in order to program the code in the microcontroller, the pins of these interface are MISO, MOSI, SCK, and along with that, this reset pin. So using these 4 pins, we actually program the code in the microcontroller. Okay. And obviously ground pin will be there because ground pin is also is actually going to be the reference pin, and with respect to that particular pin, all the signals will be interchanged between the microcontroller and the programmer. Okay, so I will write the names of the pins of ICSP interface once again. The first one is MISO, then the next one is MOSI, which stands for Master Out, Slave In. Then the next pin is SCK. And after that, the next one is reset pin, and then there is the ground pin. Okay, so these are actually the pins of ICSP interface, and using these pins, we program the code in the microcontroller. Okay, and on number of boards, or whenever you will deal with the Arduino boards, you will see a 6-pin ICSP headers. So in our case, we are actually using total 8 pins are there, out of which 2 pins are actually not important. They are actually not part of ICSP header. Only these pins which I have mentioned, these are actually the pins of ICSP headers. Okay. So on Arduino Uno board or Arduino Mega board, or if you are dealing with any other board from Arduino organization, you will find a 6-pin header on each and every board. Okay. And using that particular header, we actually program the code in the microcontroller. Okay. Now on this hardware, this is basically the debug/programming header section. So I have called it as debug/programming header. You will get that in a moment. I hope that why it is called as programming, it's because with the help of this header, we are actually going to program the code in the microcontroller. Okay. And on this header, if you see, there are actually MISO pin is there, MOSI pin is there, then SCK pin is there, then reset pin is there, and after that, the ground pin is there. Now this debug TX and debug RX pin, these 2 pins, about these 2 pins, I'm going to talk in a moment. First of all, let's concentrate on these pins only. Okay. So MISO is connected here, which you can see, which is PB4 pin. Then MOSI is here, which is PB3, and SCK is here, which is PB5. And after that, a ground is going to be the reference pin. And you already know this is basically the reset pin. So using these pins, we are going to program the code in the microcontroller. And I'm not just talking about Atmega 328 microcontroller. Okay. Whenever you will deal with any controller from the Atmega series, whether it's Atmega 8 or whether it's Atmega 16 or whether it's Atmega 32 or whether it's Atmega 256, whichever controller you will deal with from Atmega series, we actually use these pins to program the code in the microcontroller. Okay, and on this header you will have a question that I just mentioned here, 5 pins. So which is actually the 6th pin? The 6th pin is VCC pin. Okay, so we generally don't use VCC pin to program the code. We just use MISO, MOSI, SCK, reset and ground. Okay, so I hope that this is clear. These are the pins. These are actually the pins of SPI interface, and out of all these 4 pins, we just use 3 pins which are actually part of ICSP pins. So these are actually the ICSP pins, and this header is actually called as ICSP header. Okay, and ICSP and ISP, as I told you, they are actually the same. In circuit serial programming, that's basically the extension of ICSP. So I hope that this is clear. So these pins you should connect to one of the header in order to program the code in the microcontroller. Okay, after that, now on this header, if you see, there is debug RX pin and then there is debug TX pin, and these 2 pins are actually connected to these pins of this microcontroller. So we saw the USART interface, which is USART, which stands for Universal Synchronous Asynchronous Receiver Transmitter, and this interface actually includes 2 pins. The first one is RX pin and then the second one is TX pin. And I told you that whenever we have to do the communication using USART interface, at that time the data will be sent over this line, which is TX line, and the data from the external interface or from the external device will be received on this particular line. Okay, and these are actually the pins of USART interface, and we have connected these pins to this header. Now you will have a question why we have connected these pins to the header. So you know, whenever we have to send the data from the microcontroller to the computer, again we can use these pins. Okay, so the data will travel from this TX line through this header. Then there will be an external converter about which I'm going to talk in detail in the upcoming video. But the data will travel through that converter and later we will be able to see that data on the computer. Okay, so that's basically one of the application of this UART interface. That's the reason I have written here debug. So when you write the code in the microcontroller, you know, you actually do the debugging. You may need to check, or you may find a need to check which part of the code is executing. So for that, you can actually send some kind of commands on the computer, and by observing those commands, you will get to know which section of the code is actually executing. Okay, so for that purpose, we actually use this UART interface. And as I also discussed, we can also use this particular interface in order to communicate with the external communication devices. Like we discussed that we can use a GPS device or some other device to communicate with the microcontroller, and in that case we use this particular interface. Okay, now here the purpose of this particular interface is actually different. We are not actually connecting these lines just to send the data on the computer. So that is actually the first purpose. The second purpose is we are using these pins to program the code in the microcontroller. Now you will have a question. You already discussed that these are actually the pins, ICSP pins of microcontroller, and using these pins we program the code in the microcontroller. Now why we are using these pins to program the code in the microcontroller? You will have that question, and it should come. It's obvious, right? Now I will tell you why. I'm not discussing why we are using exactly these pins to program the code in the microcontroller in detail in this video. I have dedicated a separate video for that, and in that particular video I'm going to discuss it in detail. Okay, so because this is actually not right time to discuss why we are using these pins to program the code in the microcontroller. So when we will proceed ahead in the training, at right time I will explain you why we are using these pins. Okay, so at this moment you just remember we are actually using these pins to program the code in the microcontroller. The first purpose is to see the data on the terminal window. We are using it for debugging purpose, and the second purpose of this interface is actually to program the code in the microcontroller. Okay, Now again you will have a question. You told that this is the programming interface, ICSP, and along with that this is another programming interface. So are we going to use both the interface to program the code in the microcontroller every time? The answer is no. We are just going to use this particular interface, which is ICSP interface, only once. Okay. So using this particular interface, we are going to program the code in the microcontroller only once. And after that, whichever code you want to program in this microcontroller, that will be done with the help of these pins. And why we are doing this particular arrangement? The simple answer is we are actually trying to create a Arduino kind of board. Okay. And Arduino board, you will find that these pins are actually used to program the code in the microcontroller. Okay. So that's basically the simple reason. Otherwise, you can use these pins also, and you can use these pins also to program the code in the microcontroller. It's just that in case of Arduino, these pins are used. That's the reason I'm going to use these pins to program the code in the microcontroller. Okay. And also that's the reason why we have connected these pins on this header. I hope that this is now clear to you. Now let's talk about the crystal section. So these are actually the two pins of crystal which are present in this microcontroller, Xtal1 and Xtal2. Okay. And you can see here we have actually connected an external crystal of 16 megahertz to this microcontroller. There is actually, RC oscillator is there inside this microcontroller. So even if you don't connect a 16 megahertz crystal externally to this particular microcontroller, still this controller will actually work. Okay. So by default, when you purchase a fresh chip from the market, this RC oscillator will be selected inside the microcontroller. And by default, this clock source, the clocks or the frequency which will be generated by this particular RC oscillator will be used for the internal operation of the microcontroller. Okay. But in our case, we are actually using an external crystal oscillator. The reason is very simple. This particular RC oscillator is actually not that accurate. And, generally the RC oscillator actually drifts with respect to the temperature. So with increase in temperature, the stability of this RC oscillator, it's going to decrease. And because of that, we generally try to avoid the RC oscillator, in most of the application. So in our case, we are going to use a 16 megahertz crystal. Now again here, you will have a question why you are using this particular value of 16 megahertz. So I will tell you the answer for that. If you go to the datasheet of this controller, you will find that there is actually a range of frequencies which are actually supported by this particular microcontroller. And in order to operate the controller on those range of frequencies, you can actually use multiple values of crystal here. For example, you can go for a 4 megahertz crystal. You can go for an 8 megahertz crystal. So I want to interrupt at this point. This RC oscillator which is there inside the microcontroller, its frequency is 8 megahertz. Okay. So remember that point. So you can use a 4 megahertz crystal here. You can also use a 8 megahertz crystal. So you can also use a 16 megahertz crystal. So it actually depends on the application with which you are dealing. And based on the application's requirement, you need to select the frequency of the crystal oscillator. Now, generally, this particular discussion will be done between the firmware developer and the hardware developer, and they are actually mutually going to decide what crystal value you need to select here. Now, firmware developer is actually going to make the decision based on the type of code he has to write for a specific application. And based on his experience, he is actually going to tell which crystal oscillator or which value will be actually more appropriate to connect here. Now, in simple word, I will tell you why I have connected a 16 megahertz crystal. The reason is on Arduino board, you will see a 16 megahertz crystal oscillator. And that's the reason I have connected a 16 megahertz crystal oscillator here. Because we are actually trying to create a board similar to Arduino Uno board. Okay. So whatever code you will be able to program in the Arduino Uno board, the same code you will be able to program in this particular microcontroller. Okay. And that's the reason I have selected the same crystal value, which is 16 megahertz in this hardware design. Okay. So I hope that this is clear. After that, you can see here, these are actually the load capacitors that we have connected around this crystal. And these load capacitor are actually part of this oscillator circuitry. You know, these days modern microcontroller actually comes with PS oscillator. You can read about PS oscillator circuitry on Wikipedia or on internet. So these two capacitors and this crystal is actually part of PS oscillator circuitry. And inside this microcontroller, there will be some more circuitry, like there will be some buffers, which are also part of, you know, the PS oscillator circuitry. But externally, in order to operate this controller with the help of external crystal, we need to connect an external ceramic crystal, and along with that, we need to connect these capacitor for the stability purpose. So connecting this capacitor is actually very important, but it's not like if you don't connect this capacitor, these capacitors, then the controller will not work. They will work, okay? But from long-term perspective or from stability point of view of this particular capacitor, it's actually very important to connect these 22 picofarad capacitor. Now again, you will have a question from where this particular value came. So again, if you check the data sheet of this microcontroller, you will see that for different crystal value, they have actually given a different values of load capacitor. And for 16 megahertz, this is actually the value. That's the reason this value is connected here. So I hope that this particular point is now clear to you. And with that, we have discussed every single thing related to this Atmega 328 microcontroller. And we are now left with these all pins. On these pins, we are actually going to connect the different interfaces like RGB LED switch, then DC motor, 7-segment display. So I will talk about these pins and how those interfaces are connected to these pins of this microcontroller in their respective section. And in this video, that's what I wanted to tell. I hope that every single thing that we discussed in this video is now clear to you. And if you still have any kind of doubt, then definitely you can reach to me and I will help you with that. Okay. Alright, so now I will see you in the next video, which is about schematic design of microcontroller. Okay. So I will see you in the next video now.